Hello, welcome back to the AI Engineering Crash Course. Today we'll do an introduction to LLMs. This is the third part of the first module of the course, where we'll just be going through the history from the starting point till the LLM, so you understand where the LLM come from and the generations of model before LLM. So it's a high-level overview. We'll not be going through technical details or mathematics here. It's just a means for you to understand what the LLMs are and where they come from. Get started. As we said at the beginning of the course, everything started with data, and the vast amount of data that we generated online brought us to a point where we tried to find ways to use this data efficiently. So we were able to actually get this data and get some key information from the data. And from that data, we wanted to see into the future a bit. Okay, so we wanted to create some correlations between what happens before and what will happen next. And this drove us to an era where we had amazing technologies that only help to predict the future. So, say predicting the future is a bit old here, but the goal of the technology was to actually try to find correlations between data that we have right now and what could happen in the future. And this technology brought us to machine learning. And what exactly is machine learning? So machine learning is a subset of data science that study, or it's a subset of data science that actually aim at creating models that are able to predict values of new data based on past data. So let me just give you an example here. Let's say we have multiple points like this. Okay, we have a data like this, for example. The goal of machine learning is to say, hey, I'm seeing a kind of correlation here. Maybe this actually looks like this curve. And if we just in the future, maybe have a point like this here, we may guess and get its value. And this is in some kind of, something like this. I hope you understand mathematics, otherwise it's not fun. So we do this, we have this. And if the goal is to say, okay, we have this kind of correlation between the data. And if we get a point here, it's probably something related to something here, and we may get a value from it. So we have so many machine learning algorithms. We have random forest, which basically is a simple decision tree. So you have maybe a starting point here that will say, oh, this happened, then do this. But if it is this, do this, it's kind of simple. It's actually many useful classifications. We have random forests. We have many other machine learning algorithms that are quite interesting. And from this algorithm, you are actually able to either classify things or predict new value based on actual past values that you use to train the model. But the issue here is most of the time you need a strict way of organizing the data, a strict data feature extraction, which means extracting things that will influence the behavior of the model from the data. This is quite complex, especially for all the data we have online. So we try to create a new field that will be like a black box, like a magic spell. So we just give it the data. It makes sense out of this data. And then you just ask for new predictions. So you don't need to know, oh, do I need a decision tree? Oh, do I need a regression algorithm? Or do I need whatever? You just pour the data in and you get something out. And this field is actually called deep learning. So deep learning is a field where it's a subfield of machine learning, where I will just simplify things here, where we try to make things as simple as possible. So we have a set of data. We try to mimic how we think, how the human brain is created. And we give information in and we get information out. It's the same, maybe you see something and it trigger reaction, right? So a lot of neurons in your head made this reaction from the action, from the input that you got. So it's the same that we are trying to reproduce with deep learning. We have a set of neurons. it's still, rounded corners, rounded balls like this. We have hidden layers, some kind of layer. So let's say these are actually, human brains. And we have output layers, something like this maybe. And we try to connect them. It's not okay. So let me just change the color because now it's readable. Something like this. And we do a lot of mathematics. Okay, some mathematics to be okay. So if you give this input, you need to calculate the amount of a lot of mathematics things that will give you the right output based on the input that we gave. And this right output may be the prediction that we are looking for. And most of the time, it works, right? Most of the time, these models are able to capture the correlation in the data that we give to the model. This is quite interesting. So we are now able to feed the data to a kind of model and get back some kind of prediction. So we are now able to predict the future, basically. But the problem is, from this model, we cannot keep a kind of sequence. So if you give some kind of data here, you get input and output. So you are not able to give a structured data to this model here. You're not able to maybe give a text. Let's say you want to translate something from English to French. How do you build this kind of model? Let's say you want to predict stock prices. It's kind of an historical data. You need the strict order of things, but this deep learning model cannot do that. So we come up with different architectures, and these architectures included recurrent neural networks, LSTMs, and then transformers. So this is actually here to help push limits of deep learning that we had, and this helped solve the problem. I think the latest one were transformers that Google published a few years ago. When Google published transformers, we didn't really have a really big breakthrough. After that, I think Google created Google Hello, a kind of chatbot, publish it online based on that, create some models, BERT, and some few models and publish it. But it wasn't that big. It wasn't that huge. It was a great technology, but it wasn't used efficiently. But the power that comes with transformers is actually what? With transformers, with deep learning generally, you have a hard time doing it on a large scale of computer on a really, really big amount of data. So you need it's hard to scale, basically, if you have to put the software terms here. But with transformers, this is actually possible. We can do it on a cluster of GPUs. We can feed it so many data. We can do parallel training. So the architecture is good enough for scalability. And then one company, I think created in 2016, started exploring how to reach AGI. That company is actually OpenAI. And they started by trying to feed the most data possible to a transformer model. They started by creating GPT, open source, GPT-2, open source. And then in 2020 or 2021, I don't remember quite well, they created a model called GPT-3 that has, I think, 360 billion parameters or 200 billion parameters. And we started seeing new features from this model. So remember from the beginning, I said, deep learning model are kind of a black box thing. You feed the data and the deep learning model figure out what to do with it, right? So right now, it figure out what to do with it, but kind of much more than what we expected. It was able to do things that we didn't even know a model can do. So we found a pattern here. Maybe if we scale this model more and more and more, they may do things that will be more and more and more complex. And from there, we had scaling transformers, we had LLMs, large language models. And these large language models basically are just a bunch of data. So if you get a large amount of data, let's say this is data, and you properly feed it to a transformer model, using a lot of GPU and burning a lot of money as well. I think basically now it's like 6 million from the DeepSeek standard. You are able to get an intelligent model at the end. And this intelligent model will be able to have skills that you didn't predict the model will have. So it will be able to converse, to translate text, to do mathematics, to understand physics, and many, many, many more things only based on training data. So most of the time you have a completion model at the end. So here you just have a model that can complete text. So you can say, hello, I am, and it will complete, just say, oh, I'm this guy from this country doing this, because the model saw that a lot of time and know how to work with this kind of data. So what it's doing under the hood is that it is trying to predict, this word based on what it got before, right? And surprisingly, this is working. So it's able to predict coherent text. But now, in order to have a much more specific use case being teach to the model, we need a second step, which is actually either reinforcement learning or fine tuning. So we need to go from this completion model to a model that can do one thing specifically well. And we need to do some kind of supervised learning here, where we feed some real world examples to the model, like let's say a conversation or some text, some code or whatever. And the model will learn from this kind of data. And then we'll be able to do that specific things. The model actually from the base training has some kind of knowledge that will help do many, many things. But now if you specialize the models in one thing, the model will be good enough to perform that thing quite well. So from this large language model, GPT 3.5, we got Chat GPT, which is actually a derivative of the completion model specially made for text. We got coding models, we got many other models for many other specific things. And now we are here able to build incredible apps on top of these LLMs, thanks to this evolution from data, machine learning, deep learning, RNN, transformers, and then scalable AI today. So today you still have some kind of mixed architecture using transformers and mixing it with some other kind of technology or some other kind of routing mechanism. But under the hood, most of the time it's actually just scaling transformers. Hopefully we'll get a better architecture soon that will propel the model to next frontiers and maybe make them more intelligent. But for now, this is kind of the base introduction to LLMs that you may have, that may give you a high level overview of why and how we ended up with LLMs. So yeah, I hope you understood everything from this part. If you have any questions, leave them in a comment below. Thank you for watching, and see you in the next part. That will be about API and SDKs.